All right, here we go again. Another day. Actually, we are, just a reminder, nearing the end of the school year. We have about 2 more weeks, which is a few more classes, about 4, I believe. And I sent the other packets with enough stuff to keep you busy till the end of the year, but make sure you still get those turned in whenever you can, as soon as you can. All right, so what we have going on today, solve quadratic equations by using the quadratic formula. So we've covered a lot of different ways that we could solve quadratic equations. We have completed the square. We solved by taking the square root of both sides. We have solved by factoring and by graphing. Now, there's one method that is really good in that it works on everything, and that will actually be a later lesson on deciding which one is the best for what kind of problems, for what kind of equations we have, because there is kind of a best way to do things. And this quadratic formula has its strength in that it does take a lot more work. You have to fill in several of these places. So there's like 5 variables and you have to fill them all in, and then you have to do a whole bunch of steps, which it is a lot of work, but again, it works with just about any kind of problem. So how do we use the quadratic equation? First off, we need it to be in standard form. So standard form, if you remember, is ax squared plus bx plus c. And you also have to set it equal to 0. So if there's anything on this side, you're going to have to move it over to this side so that there is nothing left on the opposite side. You also want to make sure that a is positive. Okay, I think it does kind of work if it's negative. Actually, no, I don't think it's as important, but it really does help. All right, so identify your A, B, and C. So looking at our equation here, we do have our A, B, and C. So it's going to be the coefficient for those numbers. Now, leave out X. Okay, so I know that's something that I get every once in a while. The students will put X in there. X does not go in here because this whole thing was made so that we don't have to use X. All right, we don't have to use X at all. Okay, so we get our X on this side here. Now, once we know what the A, B, and C are, we plug them into the formula and then we simplify. So this is our quadratic formula. I put it here. It's in the packet as well, so you'll be able to get it. And again, it is a lot of stuff to remember. So a lot of times when students need to solve these, they usually don't memorize the formula because it is a lot of stuff to remember. And if anything's even just a little bit off, then it might not work, which is why it's a good idea to have the other one. So that's actually a weakness to the quadratic formula, is that you need to either memorize it or have it written somewhere. Or if you're taking a test, you'll most likely have to remember it or hope that it's on the information sheet that they give you. Anyway, so let's go ahead and start working on some of the quadratic formula problems. So make sure you read the directions. Solve each quadratic equation below by using the quadratic formula. So again, that is this here. So first thing we got to do is identify our A, B, and C, because right now we can see that this is already in standard form. And again, really quick, standard form means descending order in power of X. So X to the 2, X to the 1, and X to the 0 power. And sometimes these are mixed up, so you got to make sure they are in the right order. So first thing we got to do is look at what is in front of here. So this is where A is. Now, if you don't see anything, it's going to be 1, right? Because there's a hidden 1 right there. If there's nothing there, then again, it's 1. And then here, it's going to be 2. So let's get our B value, which is 2, and C is going to be negative 63. So there we go. We have all of our variables, A, B, and C. Now we're going to take these and plug them into our formula here. So let's go ahead and plug it into our formula. So we are going to get negative B. So take our B value, and we're going to have to make that the opposite. So even though it says 2 here, the formula says that we have to change the sign, or in this case, since it is positive, we plug it in here, and it's going to have that negative on it now. So just remember, it just switches the sign. Now this plus and minus you might remember back when we were completing the square, we did that thing where once we take the square root of both sides, we would use a plus and minus symbol. Now, just a quick hint, I'd like to go over this in depth, but this is actually solved for x by completing the square. So you use one method to get the other, but now they put it in one formula that you can just look at and plug things into, and it will immediately, you'll get it. So let's go ahead and take the square root. So here we have b squared. So let's look at our b. So 2 squared minus 4. And that number is always going to be a 4. That's one of the constant values that you would have here. And now we need to put a in there. So I'm going to put a, which is 1. And then next one will be c. So I'm going to put in negative 63. And to make sure that this goes all the way across all of the top numbers. And then bottom number is always going to be 2, and then 1 for our a value. And again, this is quite a bit of work. There is quite a lot of setup to this type of problem. But the good thing is once you get it set up, it will hopefully kind of go by a little bit easier. Again, it's a little bit of work, but it's a little bit easier because all you're doing is just evaluating this using each of these operations. So negative 2 plus and minus. Now, one other downside to this is that I do run out of space quickly, so I'm going to try to fit some of these in wherever I can. All right, so plus and minus square root. I'm going to open the root. And then 2 squared, so this is going to be 4. So 2 squared is 4, minus, now here it kind of pays to look ahead. So I have 3 numbers that are being multiplied, negative 4, 1, and negative 63. So there's actually 3 numbers. So first thing I'm going to do is I'm going to look at the sign. In this case, I have 2 negatives. So negative times negative is going to be positive. So positive, because negative, negative. And now I am going to multiply the remaining pieces. So in this case here, I have 4 times 63. Just use my calculator to keep things going a little bit quicker. And that's going to be 252. 252. All over 2 times 1, which is just going to be 2. And like I said, you do run out of space in this fairly quickly. So I'm going to go ahead and do this. Now, I'm going to go ahead and maybe for this first one, I'm going to not skip any steps. And I'll try to do as many as I can without skipping steps. But again, you do need a large workspace to do all of this. So in this case here, I'm going to go ahead and add 4 and 252, which is 256. Now, in this case here, you got to think back like maybe 2 or 3 weeks ago when we were learning square numbers. One of the square numbers that we learned was 256. So that's why it's a good idea to memorize them. Okay, and not just memorize them for one assignment because it's always going to be coming back and being in handy a lot. So in this case here, this would be, I'm gonna break it into 2 parts from here, just again, negative 2 plus, and I'm using the top one, the plus, and take the square root of 256, which is, in this case, it is 16. And I'm gonna do the same thing, but I'm going to minus now. So again, there are 2 possibilities, a plus and a minus. Then from here, I have 16 minus 2, which is negative 14 over 2. Oh, wait, no, that'd be positive 14, sorry. 16 minus 2 would be positive 14, and 14 divided by 2 would be 7. So actually I have one of the solutions. And then here I have 2 negatives. So remember, in this case, if there's 2 negatives, they're going to combine to make a bigger negative. So in this case, I have negative 18 over 2. So 18 divided by 2 would be 9. I don't know why I needed a calculator for that. And that would be our second solution. And just like any kind of equation, if you have a 2 power, you might have 2 solutions. So now we have both of our solutions in this case. So let's go ahead and write that down. X equals, and we're going to have our set again because there's 2 answers. and put them in numerical order. So the lower number and then the higher number, or the greater number, lesser, greater. So again, numerical order from going down to up. So there we go. Now we have both our answers. And again, it is a little bit of work, but again, it always works. It'll work pretty much all the time. Anytime you have anything and you're not sure what to do and you know the quadratic formula or you have it available to you, this is probably one of the most reliable ways to get an answer. All right, so let's go ahead and move on to this one here. And I just, a heads up, I might have to erase some of this. So make sure you get that down before we get to this next part here. So first thing, let's go ahead and plug in our A, B, and C. Now, when you have a negative, don't forget to bring that negative with it, with that number. So negative 11, negative 10, all right? So if it has a sign, it goes with it. If there's nothing there, then it's positive, or if it's a plus, then you just leave it alone, like we did here. So plus 2x, and then we just left it at 2. All right, so there we go. Now we have our 3 variables. Let's go ahead and plug them into our quadratic equation, quadratic formula, sorry. And here I'm gonna go ahead and put B, so that'd be negative 11. Now this one's a little bit of a weird one because in this case, our formula comes with a negative, but we also have the 11 bring its own negative. So we end up with 2 negatives. We got to have the plus and the minus because again, there's 2 possibilities whenever you're taking the square root of something. Just a reminder, it's like if I said, what numbers can I square to get 4? You know, everyone's going to say 2 times 2 is 4. So 2 squared is 4, but then you can also have negative 2 times negative 2, or negative 2 squared, and that would still be positive 4. So you have to have both possibilities. Now let's go ahead and put in B squared. And if it's confusing, you can put in a parenthesis. You notice I did not do that here because squaring a positive number is pretty easy. But if you're unsure, you can put it in a parenthesis, so that way you know the 11 had brought its own negative. And that way you know it's negative 11 times negative 11. Sometimes if that negative is left out, it'll change it'll change stuff down the line. All right, so here we got 4AC. So A is going to be 6, and C is going to be negative 10. So it looks like we're going to have a pretty big number under here, under our radical. And I'm going to double check it, make sure I put all of the right numbers in there, which it looks like it is. All over 2 times A, which in this case we have an A value of 6. It's normally 1, but sometimes it'll be 6. Now, thinking about it, I mean, just looking at this before we start, just look at this and think, how would I factor that? See, factoring this would be kind of tough because you have an A value, right? So that means that you're going to have a lot of guesses because you need something that'll also factor to this, that'll multiply to that and add to this. Yeah, okay, so if that sounded difficult, that's because it is. So that's why quadratic formula works out. That's why it exists. So let's go ahead and evaluate this. Now again, opposite of negative 11 would be positive 11. Plus and minus square root negative 11 squared. So that is, well, negative 11 times negative 11. Well, we know it's going to be a positive, and 11 times 11 is going to be 121. And again, I have 3 numbers being multiplied here. So negative 4, 6, and negative 10. And I have 2 of them that are negative. Since I have 2 that are negative, I'm going to take care of the sign first. So negative times negative is positive. Now, no matter what order I multiply these numbers in, negative times positive is negative. Well, then the product of these are going to be negative times negative 10. Or if I did it this way, or do 4 and 10 first, it's always going to cancel out. So that's why it's going to be a plus. So if you have an odd number of negatives, then it's going to be a negative. If you have an even number of negatives multiplied, then it's going to be positive. Anyway, 4 times 6 times 10. So 4 times 6, 4 times 6. It's going to be 24 times 10. 24 times 10, well, that's easy. 240. All over 12. Now I'm going to try to not erase this if I can help it. So I'm going to go ahead and move over to this side here. So 11 plus and minus square root, and I'm going to add 240 together with 121. And that's going to be 361 all over 12. Now I do have a bit of a problem here, and let's see. Is 361 a square number? I have a chart. Now my chart on the wall does not go that high. So in this case, I think it might be a good idea to have a calculator. So that's what I'm going to do. I'm going to switch over to the calculator here. 361 divided by, well, actually not divided. I need to take the square root of it, which in this case, we get a nice root number. We get 19. So now I know that this is going to be 19. Go back over to here. And now that I know what it is, I'm going to go ahead and break it into the two cases. So I'm going to, again, break it into two possibilities because, again, we have to consider what if it's the plus. And in this case, we have 19 over 12 and 11 minus 19. So again, that plus and the minus is here, plus, minus. So we have to do both of them. All right, so 11 plus 19, 11 plus 19, it's going to be 30. So 30 over 12. And anytime you run into a fraction, check for two things. See if you can divide it, which in this case, well, I guess you could divide it. You could get like 2, but then you'd have a fraction left over. But let's also simplify it as well. So think of the largest number that can divide both of these. And you might be saying, well, they're both even, so I could divide them both by 2 and I'd have 15 over 6. But that wouldn't be the simplest form because, well, there's a bigger number you could factor out. You could also do 3, right? Because 30 can be divided by 3 and 12 can be divided by 3. But hold on a minute. If we did that, we'd have 10 over 4 and they would still be even numbers. So there's probably a bigger number I can divide by 30 and 12. That would be 6. So 30 divided by 6 is 5, and 12 divided by 6 would be 2. So in this case, I have my first solution here, and now I can work on my second solution. And this one might be the same way. So I'm going to go 11 minus 19, and that would be 8. Well, in this case, negative 8 over 12. And same thing, they're both even, so you might think, okay, well, I can just divide both of them by 2 and I'd have 4 over 6. But they would still be even. And you could divide it again by 2 right there, 4 over 6, that'd be 2 over 3. Or divide both of them by a larger number. So in this case, 4 can divide into 8 and divide into 12 and give us nice numbers. So divide this by 4, we get 2. Divide this by 4, we get 3. So 2, well, in this case, negative 2/3. So now we just got to write our solution, and I'm going to have to put it somewhere like maybe right here where I actually have space. So x equals, and put them in numerical order, negative 2/3 and 5/2. Put a box around it, especially in a problem like this. See how much stuff we have going on here? With all that stuff going on, it's kind of hard to tell where the answer would be. And even though you could probably just leave the brackets or the braces there, you know, it'd probably be pretty good to see where the answer is. But boxes just make it help out. Stand a little bit longer. All right, so there we go. We got it. Now in this case, again, remember how I said before we started this problem, I said, think about factoring it. Well, you'd get fractions, which is not impossible. But if you remember factoring with fractions, that was a lot of work. You had to use the AC method and you had to do a whole bunch of like adding this and multiply that and then put it back when you're done with it. You know, borrow a number and put it back. Yeah, so that's why the quadratic formula is there. Again, it has its own times that it becomes very useful. All right, I'm gonna move on to the next one. And I'm gonna kind of go through these a little bit quicker as we start getting more and more used to this. So first thing we gotta do is check to see if it's in order, which in this case, this is not an order. It should be equal to 0, okay? It should be equal to 0. It should not be equal to 1, which in this case here, that means I am going to have to fix this. So I'm gonna put an arrow here just because I don't want another equal sign. So that arrow shows that it's the same thing as this. We're just kind of doing some work on it. Negative x squared plus 2x. So those don't change because it's pretty much the same thing. But I am gonna have to minus 1 from both sides. And as I minus 1 from both sides, the 1 goes off of this side and onto this side. So now it is in the right form. So now this is the one that I'm going to have to use in order to get this, okay? So A is -1, B is 2, and C looks like it is also -1. All right, so I think we're ready to start plugging things in. So grab our formula, and I know sometimes it'll be a little off the screen. And like I said, it's on the packet, but I put it up here so that way we can always look at it. All right, so negative b, so let's go ahead and put negative b. So here I have 2, but remember it's got to be negative, or switch the sign, plus and minus square root of b squared, 2 squared minus 4 ac. So in this case I have -1 and 1. So my C value, wait, hold on a minute. Both of those are supposed to be -1, so I'm gonna put that there. That's why it's a good idea to check it really quick. Make sure you're putting the right numbers in there. Now, actually, I also remembered that on the last one I ran out of space, so I'm gonna move it up here. All over 2a, so 2 times -1. So there we go, we plugged in everything. So everything has been substituted, all of our variables. Now let's go ahead and evaluate some of this, and I'm gonna do multiple things at once. Just because if I had to do every single step, you know, I'd have like 1, 2, 3, 4, 5, 6, 7. I'd have like 7 different steps. So by doing multiple things at once, I'm able to save some of those steps. So -2 plus and minus square root of 4. And now for these ones here, I'm gonna need to check the signs. In this case, I have 3 negatives. So if I multiply the first 2 negatives, that's going to make it a positive. Positive cancels out. Positive times negative is going to be a negative. Okay, well, what if I multiply the back 2, okay, the last 2? Well, that would be positive. Positive times negative is still going to be a negative. Well, what if I do the ends, you know, the 2 on the ends, this one and this one? Well, those are going to cancel each other out, and I'm going to have 1 left over. So I'm always going to end up with a negative. And if you remember, multiplication is commutative, which means no matter which order or which one you multiply first, you're always going to end up with the same number. So in this case, I am going to end up with a negative. Now here I have, well, I know it's going to be negative. So let's just, from here, ignore the signs, okay? Let's just go 4 times 1 times 1, which is pretty easy because, well, that's just going to be 4, right? Because that's one of the other properties. 1 times anything is not going to change it. That's the identity property. All right, now I'm going to go ahead and do this part here. So 2 times -1 is going to be -2. And I am going to, okay, so something kind of weird happens here. And this is actually going to tie into a future lesson, because we do have something that's kind of odd here. 4 minus 4. Would be 0. Well, what do we do if there's a 0? Well, what is the square root of 0? And like I said, if you have a calculator, you could kind of get that on, you know, kind of work that out. But it is going to be 0, because 0 times 0 is how you get 0. So the square root is what numbers can multiply to get us 0, which in this case, 0 times 0. So that's going to be just 0. So as I break this into two parts, -2 plus 0, well, that's not going to change anything. Now, normally I would skip this and just say, okay, well, here's what it's going to be. But let's go ahead and work on this because I want you to see what's going to happen. All right, so again, I broke it into two cases, one here, one there. So -2 plus 2, I'm sorry, -2 plus 0 is going to be -2. So I get -2 over -2. And now I have -2 divided by -2, which is just going to be +1. And there's our first solution. -2 minus 2, which is also identity property, right? If you add 0, it's not going to change anything. So it would stay -2. And here I end up with pretty much the exact same thing that we did in the previous one. Now, earlier we talked about, well, like this was like 2 weeks ago, we talked about number of solutions. So remember, with a quadratic, let's draw some simple graphs here. There are three possibilities. The most common one is two solutions, and that's where there are two contacts with the x-axis by the parabola and the x-axis. So it crosses one here, one there. And then you could also have one solution, which in this case, our graph would probably look something like this, where you would have a single point of contact with our parabola and the x-axis at 1. So, you know, I'd be willing to bet, oh, no. Actually, I take that back. Because this is negative here, it would probably look more like this. Not that it's really important for this lesson, but you would have a single point of contact at 1 right there. And then you could also have a no solution where your line does not contact the x-axis. Just a quick, again, reminder. Let's write our answer here. So x is equal to, well, we only have 1. And when we're writing a set, we usually don't include the same ones over again. So we don't say 1, 1 because it's the same number. It's the same point of contact on the graph. So we don't need to say 1, 1, all right? It's like if somebody asks you how old you are, you don't say, well, I'm just gonna make up a number because I don't know how old you are. You don't say people, oh, I'm 16 and 16. What's that supposed to mean? See, it doesn't make sense to say the same number over again if it's one or the same thing you're talking about. So anyway, we only have one solution in that case. Let's go ahead and move on to the next one. And for this one here, let's go ahead and look at what we have going on here. And it looks like we do have a little bit of stuff going on because this is not in order, which means we're gonna have to do a few things to make it in order before we start. All right, so let's pick a side. And I don't know which side would be better, but I'm gonna move everything over to this side. So minus 4x, which means I'm gonna have to minus 4x here. And I'm also gonna have to plus 15, which I don't actually have enough room to put plus 15. So I'm gonna do a little bit of a rare thing. I'm gonna put plus 15 on the top. This is gonna cancel, this is gonna cancel. So now I should have nothing on that side. So nothing affects the -2x squared, so that stays. I'm also, now again, go back down in terms of power, 3x minus 4x would be -1x, which I don't, actually at this point I really didn't need to put the 1x because I could have just said -x. But in this case here, we're not done with this, so this is not our answer, so let's keep, you know, it might help to keep working with it. And here I get 15. So now we can fill in our numbers. So A is -2, B is -1, and C is 15. So again, we got quite a lot of stuff going on here. Oopsie. All right, don't need that to bothering me. All right, let's go ahead and plug it into our equation here, our formula. So -b, which in this case, it should be -1. All right, but if you remember from one of the other examples, let me back up here. Negative times negative, or, oh wait, here it is, sorry. Yeah, negative and negative, that's just gonna make it positive. So I really should put negative and negative like that. But I also know that it's just going to reverse the sign of whatever b is. So if b is -1, it's going to be a positive 1. Plus and minus square root of b squared, so -1 squared, minus 4 times our a value times the c value. And make sure this thing goes all the way across here. And then let's see, 2 times 2a, which in this case, our a value is -2. So put -2 in the bubble there. All right, -1 times -1. So that would be +1. Check your sign. In this case, I have 2 negatives. That means that they're going to cancel each other out because -4 times -2 is going to be 8. So 8 times 15. Now, sometimes it's a little bit tough to get numbers, 8 times 15. If I ask most people that, they're going to be like, 8 times 15. So what you can do is pick another set of numbers. We know this is going to be positive because there's 2 negatives that'll cancel each other out. So let's go with 15 times 2. That would be 30. 30 times 4, or 4 times 3. 4 times 3 is 12. But we also know that it's not 4 times 3, it's 4 times 30. So put that 0 back. And now we have 120. Another little helpful tip there. All right, now let's go ahead and move this over here. So I'm going to put these two together so I get the square root of 121. Now this one I immediately recognize as a square number. In fact, I think we've had this exact one before. Did we? It's not important. All right, so let's go ahead and break this down into 2 cases now. 1 plus, and the square root of 121 is 11 minus 4. And I'm going to do this one first here. So this is going to be 12 over -4. So 1 plus 11 is 12. And again, we should check to see if we can divide it, which in this case, I'm pretty sure we can divide this. 12 divided by -4 would be -3. So there's our first solution. All right, now I'm going to go ahead and do the second one. This way I know I have enough space to do the whole thing. 1 minus 11. So in this case here, we're subtracting a large number. So that means it's going to be a negative. So negative over negative, that's going to be a positive. But in this case, again, let's just leave it as fractions. Okay. I mean, you could do this. You could put it as like 2.5 or 2.5. Which again, you cannot, but I'm going to keep it simple. I'd rather kind of focus on the actual lesson. So we know it's going to be a positive number, 10 over 4. So let's divide each of those by 2, which it works out. So 5 over 2. And again, if you want to make it a mixed number or what do you call it? Mixed number, a decimal, that's fine. Whatever helps you. But the negative is also going to cancel because if you have a negative divided by a negative, it's going to end up being positive. And this looks like it is our final step. I don't see anything else we can do from here. So let's go ahead and put in our answers. So I'm going to put in my numerically lesser one first. So that's going to be -3. And positive numbers, if you remember, are always greater than negative numbers. So if you have a negative and a positive, put your negative first and then your positive. Okay. At that point, it doesn't matter which one's farther from 0 or which one has the higher absolute value. There we go. And I'm probably not going to be like super strict on that rule, but it is something that you got to watch out for. Now, how am I doing on time? Okay, we're about halfway, and if it comes to it, we may or may have to split this into another day, but I'm trying to remember. Oh, well. No, actually, I have a whole hour left, I think, if I use the entire class up. But okay, like I said, I'm going to be moving a little bit quicker. So hopefully by now we should look at this and say, okay, this is not in order. So let's leave the x squared where it is. and I'm going to minus 24. And remember to keep out for like terms, because I can already imagine some students doing something like this, minus 1 minus 24. And then they're going to use this to be the B value and this to be the C value. But you can see there's a problem with that, and that is these are like terms. Since they are like terms, we should just put them together. So in this case, it would be negative 25. Now, we got to make sure it's equal to 0, which we got rid of this 24 on this side. So now there is nothing. So that's going to be equal to 0. Good. But hold on a minute. This doesn't look like our regular quadratic standard form. There's no B value. Now, in this case here, if you were to ask me what is the best way to do this, I would say use factoring. In fact, this would be a difference in squares, right? With a difference in squares, you can see that this would immediately be something like 3x minus 5. And then our answer would be something like 5 over 3 or something like that. So in not all cases, quadratic formula is not always the best one. But since this lesson is called quadratic formula, we are going to use the quadratic formula. But I'm just pointing out that there are faster ways to do this. And it doesn't work on all of them, because if we look at some of those other ones, yeah, there's no way you could have used any of those other methods on some of those problems. So let's go ahead and plug things in. So A is 9. B, there is no B value, so we're going to have to put a 0 there. There's like no B at all. Okay, it's not 1 because there's not even an X value in there. So let's go ahead and put that in here. Now, plug it in. We're going to have to kind of fill in B with a 0. So let's go ahead and do that. 0 plus and minus 0 squared. And this one's going to make it kind of easy, actually. Minus 4AC, which our A is 9 and our C is negative 25. Yeah. 2A all over 2A. Don't forget the A value. I know it's not a lot of students, they tend to think that A is always going to be 2. So they always forget that there's, another number with the bottom number. Okay, so let's go ahead and multiply these together. And in this case here, I could probably just drop this whole thing because 0 plus and minus isn't going to make a difference. Now, if you really want to keep it, I don't see any reason why not. But I'm going to go ahead and throw it out. Just because 0 doesn't usually make any difference. So here I'm going to have 0 minus, and 0 minus anything is just going to be that same number. So negative 4 times negative 25. So a negative times a negative is going to be a positive. 4 times 25 is 100. 100 times 9 is 900 over 18. Okay. Now 900 is a pretty big number. Even if I told you to remember the chart, I don't think it goes that high. I think the highest we went to is like 400. So let's go and take 900 and take the square root of it, which in this case, 900 is made from 30 times 30. So that is the root. Oops, wrong button. All right, where was I? Oh yeah, 30. Now be careful, because in this case here, don't forget the plus and minus. Even though I said throw off the zeros, we still have the plus and the minus. Plus and minus 30 over 18. And in this case here, since we have a nice plus and minus, it would be both of whatever this number is. Now let's go ahead and reduce these numbers. Use simplify and divide both of 30 and the 18 by the same number. So the biggest number we can think of would be like 6. Yeah, I think it'd be 6. So 30 divided by 6 would be 5, and bottom number 18 divided by 6 would be 3. Now remember, just by looking at this, before we even started, I said I think it's going to be 5 over 3. And it looks like I was right. So sometimes, again, it works, but you have to kind of really know a lot to just look at something and immediately think, okay, this is what we're supposed to do. All right, like think about an expert, right? So like an expert, I don't know, mechanic or something, could, just you just tell him your problem and he'll probably be able to figure it out and say, hey, you know what, you should try this, or, you know, something like that. But if you have an expert, they'll usually be able to pick out a problem like that. So not everybody's an expert. So if you did this, you know, it's not a waste of work. That's what I'm trying to get at. You're not wasting work. And I'm trying to think of how I would write this. You could use the plus and the minus sign, just like this, you know, make it look like that, and that's fine. But I also want to show that it's going to be, oops, put a plus there. I also want to show that it's going to be two numbers. So I want to show that there's going to be two separate solutions to this. So just a quick thing, if I were to draw this parabola, it would probably be very narrow. And it would, well, okay, not be very narrow because you have a high A value. And it would cross at -5/3 and +5/3. And again, too, I'm just trying to relate to previous lessons, just that way you don't just forget it, because I know that's what happens. Out of sight, out of mind, you know. It's the way students are. You hide something and they just believe it no longer exists. All right, so let's go ahead and move on to the next one. I think we're done with that one. I don't see anything else we need to do. All right, let's go ahead and do this one here. So it looks like we are missing some of our values again, and it's still not solved to be in the standard form. So in this case, I'm gonna have to get rid of everything on one side. So I'm gonna have to minus 10x from both sides. 8x squared minus 10x equals 0. Now in this case here, we are missing one of the terms. So let's go ahead and fill in what we know. And this is why it's a good idea to fill in what you know. So I know that A is 8. I know B is -10, because again, it's not where it goes. So in this case, we're missing the B value because we have no X number. On this one, we have an X number, but we don't have a regular number. We don't have a C value. Since we have no C value, it's going to be 0. And there we go. So we got that one identified. So let's go ahead and start plugging things in. So 10, now again, remember, it's going to be plus and minus. So it's going to be opposite of -10, which is +10. Square root of B squared. So here I have -10 square minus 4A and C. Now that if you notice that with this one here, we kind of had a weird thing where we had some of the things drop out. Well, something similar is going to happen over here. So I have 2 times our A value, which is 8. There you go. All right, so let's go ahead and find out what's underneath this radical, which is actually kind of important, and that's also going to be a later lesson. -10 squared, so -10 times -10. Well, -10 times -10, it's going to be 100, because negative times negative is going to be positive. 10 times 10 is 100. Minus, and then here I'm going to have 4 times 8, which is 32, and then 32 times 0 is 0. Okay, see though, that's what I look like right there. So actually in this case, I don't really need the -0. Again, identity property. If it doesn't change anything, we don't need it. Minusing 0 is not going to change it, so let's just throw it out. Okay, less things to do, one less step. 2 times 8 is 16. 10 plus, and then let's take the square root of 10. In fact, I could break it down into 2 different formulas right now. 2 plus 10 over 16. And I'm going to do this one like this here. So 10 minus 10 over 16. Now, one of these I can immediately tell what's going to happen. 10 minus 10 is going to be 0. And remember, when you have a fraction problem, that's like a division problem. 0 divided by 16, well, 0 divided by anything is going to be 0. So we already know one of the solutions is going to be 0. Let's do this one here. So I got 20 over 16. because in this case, I'm adding the tens. Now again, I have another fraction and I'm gonna have to simplify this. So think of the largest number you could divide out of 20 and 16. Now I'm gonna do something a little bit different. Normally I look for the biggest number I could divide both of them by, but in this case here, I'm gonna just go with the first number I can think of. Now, if you do this, it works out, but you gotta keep checking it. Well, because if you put 10/8, that's not simplified. Fractions need to be simplified all the time. So if it's not in simplest form, you're gonna have to do it again. So I'm gonna divide them both by 2 because 10 and 8 are both even numbers. So if I divide it by 2 again, I'm gonna get 5/4. And those are my two solutions, 5/4. All right, so now I have both my solutions. Let's go ahead and write it down into the proper format, into set builder notation. So X is the set of 0 and 5/4, which you would probably get something like 1.25 if you were using a decimal. And again, if you get stuck on a problem, just go ahead and use decimal, because I know some of these do have problems that really require a lot of knowledge on fractions, but most fractions like this one would be pretty easy. You could say 5/4, like we did here, or you could say 1 1/4, or you could say 1.25. Again, pretty much anything I'll accept it as long as it's the same value. Sometimes you can say the same number multiple different ways, and I think we're actually done with this one here. So let's go ahead and move on to the next one, which I think there's only going to be 3 more left to go. All right, here we go. Ready? Same thing. It looks like we're going to have to put this in order, which means I'm going to have to minus 4x from both sides. And I'm going to have to put the x in the right spot. So it belongs in here. So x squared. And I got to make sure I put the sign there too. So this is going to be minus 4x because that minus goes with it. Okay. And then the negative, here we have a -9. So that 9 always has to have that negative with it. So there we go. I think this is set up. So yeah, because there'd be nothing left on this side since we canceled everything. So again, we got to set it to 0. So again, A is 1. If you don't see anything in there, it's 1. Now in this case here, it's not 0, okay, because you remember with the 2 last ones, one of those terms was completely missing. If it's completely missing, then it's a 0. But if you have something but no number, then it's 1. And then this would be -4, and this would be -9. Okay, now, I think we're ready to set it up. So -b, so let's go ahead and get -b. Now, again, there's a negative here and a negative on the 4. So I'm going to skip a step and just go straight to 4. Plus and minus the square root of b squared, which in this case is -4 squared, minus 4 times a times c, all over 2a, which in this case is 1. There you go. So setting it up, again, hopefully you're getting the hang of it because we're just plugging these in, what we get here. 4 plus and minus the square root of -4 squared. So this is -4 times -4. That would be positive 16 minus, hold on a minute. Looking at the signs, we have a negative here and a negative here. So that's 2 negatives. They're going to cancel each other out at some point. So well, let's just go ahead and go with positive. 4 times 1 is 4, and 4 times 9 is, I think, 36. 4 times 9 is, let me just double check that. 4 times 9. Okay, it is 36. There we go. Now let's go ahead and put 36 plus 16 together, and it looks like we're going to get 52. Square root of 52. Now 52 is not a square number, so we are going to have to come up with something to fix that. So what can we do with square root of 52, because it's not a square number? Well, if you remember, like a week ago, we worked on simplifying square roots. So if you simplify square roots, you're going to have to break down the number in here. So I'm going to do it up here. So 52. Well, think of two numbers that you could multiply to get 52. Now, in this case, you have a bit of an advantage because I can see the factors that make up 52. One of them is already 16. 16 is already a square number. So in this case, I go 4 times 13, which means that 4 is the number that I'm going to take out. So 4, just to remind you what that looked like. That means 4 times 13. Since 4 is a square number, I can take that out. 4 plus and minus 2 root, and 13 stays in there because 13 is not a square number, and it actually has no other factors besides 1 times 13 that we can take out. So in this case here, there's not much else we can do. We would get an irrational number, you know, one of those numbers that repeats on and on in the decimals. But we should also do something else. Now, we're not done with this one because like any kind of fraction, because this is still technically a fraction, we're going to have to divide this by 2 and divide this by 2. So 4 divided by 2 is 2, plus and minus this 2 divided by 2. So it's kind of like distributive property, but with division. 2 divided by 2 is 1. 1 times 13 is 1 times root 13, which again, because of identity property, we're not going to have to do that. Now, my bottom number is 1, which dividing something by 1 does not change it, so I'm going to go ahead and leave it out. We did manage to divide both of those by 2. And in fact, this is actually going to be our final answer because, again, we will have an irrational number. Which means it's going to be, again, a root of a non-square number or a decimal that will repeat on and on forever. I'm sorry, not repeat. It'll keep generating kind of randomish numbers forever. Well, that's not exactly the definition, but close enough to understand, hopefully. But again, we can't go any further with this one. This is as far as we can go into that. So we're just going to leave it like this. Even though it has the plus and the minus, we don't need to separate it. In fact, it's probably better we leave it like this. Now, back to the best way to solve these, there is actually, as far as I know, maybe no other way you could solve this. Maybe you could solve this by completing the square. No. Well, maybe you could, but it would be pretty difficult. But this is one of the problems that quadratic formula is made for, because this would be very difficult, if not impossible, for any of the other methods, all the factoring, completing the square, square rooting both sides, you know, all of those would be really difficult to get this kind of answer. But it's just so good to have quadratic formula that it works on everything, including stuff like this. All right, so let's go ahead and move on to the next one here. So again, I'm trying to pick up, let's see how much more time I got. I think I got 1, 2 more slides to go, okay. Okay, so got to get all this solved. So minus 8x, which it looks like that's, oops, not 18, minus 8x, and then add 1, cancel, because those are gone. That's what we want, negative 2x squared minus 8x. Make sure you put them in right terms, okay? Don't add this to the 17. But the 17 and the 1 can be added together. And you would get something like this. Now, in this case here, so we add 1 to both sides. I think we can do something with this. I think I could divide everything by 2. But if you're not sure, it just works with everything. So I mean, I think there's a shortcut here, but that, you know, today our lesson is learning how to work with this thing. So it looks like we're gonna have to use it as much as we can. All right, so b squared, so sorry, negative b. Negative b is 8 plus and minus square root of b squared. So negative 8 squared minus 4ac all over 2a. Double check to make sure everything's put in the right place. Okay, now let's go ahead and put these all together. So 8 plus and minus square root. And this is going to be 64 plus 4 times, okay, let's see if there's an easier way I could do this. 2 times 18 is 36, and 36 times 4. Okay, 36 times 4, and that's going to be 144. Negative 4. And then 8 plus and minus. 64 plus 144 is going to be 208, which I don't think that's a square number, or is it? Because I know 64 is a square number and 144 is a square number. Is 208 a square number? I don't believe it is. That is kind of weird, actually. I would imagine that would be a square number. Oh well, keep going. Because I mean, there's again a square number plus another square number. I guess it doesn't always work out that way. All right, so 208. Let's get a list of multiples that we could use. Now, again, sometimes you could do this pretty easily. So let's think of the biggest number we could divide 208 by. That'd be 4. 4 times 52. Now, you could probably take another number out of 52. Because, okay, so what I'm going to do is I'm going to divide 1 in half. So that's going to be 26. If I divide 1 in half, I have to double the other one. So that's going to be 8 times 26. And you can double check this on your calculator, 8 times 26. That would still be 208. But again, neither of these are square numbers. 4 is a square number, but I think we can get one bigger out of it. So I'm going to do the same thing. I'm going to double this one, and I'm going to half this one. 26, that's a terrible looking 13. There we go. 16 times 13, 16 times 13, and that's going to be 208, and that's good, it works. And 16 is a really large square number. So remember, this means square root of 16 times square root of 13. So I'm going to take the square root of 16, that'd be 4, and here I have 13, which is going to be excuse me, the one that stays in there and we can't take it out. Now we run into a similar thing that looks, well, similar to the last one. When this happens, try to divide it, okay? Sometimes you can't divide it all the way, but try anyway. And if it helps, since I have room, I can do it this way too. I can split that negative 4 so that they are under both of them. Now, sometimes again, this doesn't work. So I don't know. Maybe I think we are going to have one later on that's like this. But if you can divide both coefficients, in this case, 8 and 4 can both be divided by negative 4. So we are going to do that. So in this case here, negative. We're going to get a negative. So 8 divided by 4 is 2. Plus and minus 1 times root 13. Now, in this case, we don't really need the -1 because, you know, if you add or plus a negative number, it's going to be the same thing. So I'm going to go ahead and get rid of this and just go with plus and minus. Now, if you put -1 times root 13, I would probably still accept that because technically it is right. It's not the simplest form, but it's also not something that we use all that often. Pretty rare, actually. So since it's so rare, I would just imagine I'm going to just let it go. So let's just write our answer because, again, this is an irrational number. Since it is an irrational number, let's just simplify it as far as we can go, and we will go ahead and call it done. All right, so that is it for that one. And again, this is about as far as we can go. I'm going to go ahead and keep going. I'm going to have to pick up the pace a little bit, just because, again, time. And then this is a fairly, well, it's not really a long lesson. It's not, in my opinion, it's not really that much more difficult than a regular problem, a regular type of thing. There's a lot of work that goes on. And again, that's like the downside of quadratic formula, is that there's oftentimes a lot of steps that you have to do. But again, it works every time. There's not really a way you could mess it up unless you put something in the wrong spot. All right, so there you go. I set it up. Let's plug it in. B squared, which is 0 squared, minus 4, and I'm using this thing over here, minus 4 times A times C. Make sure we put this over here, all over 2A, which in this case our A is -8. There you go. Now again, I'm going to just throw this 0 out. We don't really need the 0, but we are going to hold on to the plus and the minus. Square root, and this is going to be 0. And let's see, we have -4, -8, so we have 2 negatives. That's going to make it positive. So let's just go 4 times 8 times 3. And I don't know if there's a best way to do this. Okay, 4 times 8 is 32. 32 times 3. And that would be 96. And again, that 0 just drops everything out, and this would be over -16. Now, is 96 a square number? No, it is not. And I can double check that on my calculator, because if I did that, it would be 9.7979589, and that's as far as I can see, but it is not going to be a nice number. So we're going to have to break this number down. So let's go ahead and get our factor list or a number. We could use either a number, factor tree or factor list. There's 2 of them. But I'm going to just stick with the one method and use a factor list. So let's go with 4. I'm pretty sure I could divide this by 4 because 4 times 24 is 96. So if you think of 4 times 25, like 4 quarters, that'd be 100. Just minus 1 4, and then you would get 96. Okay, don't worry about that. Now let's do the same thing what we did with the other one. I'm going to double this number, and I'm going to half that number. And I'm just going down the line thinking of what are the largest numbers that I could factor out. In fact, in this case here, I could probably also go with 6 times 16. And I would, again, just pick a number. And okay, so like 1, I can divide it by 1, but I'm pretty sure that's not what it is. I could go 2 times something to get 96, but I'm trying to get square numbers, which in this case, it looks like the largest square number is going to be 16. Which, remember, that means the square root of 6 and square root of 16. So I'm going to take the square root of 16. Take the square root of 16, we get 4. And our leftover is going to be 6. I can't take that 6 out, so it's just going to stay. Now, it looks like I'm going to have to factor this down again. Now, remember how I said sometimes you get whole numbers, like if we look at our last examples, they became no more fractions. They basically became whole numbers, even though they are irrational. There's no fraction is what I'm saying. Okay, there's no fraction part of these numbers. Here, I cannot divide 4 by 16. I mean, I can divide 16 by 4, but I can't go the other way. So I'm going to have to simplify it. Divide this by 4, divide this by 4. That'd be 1, but again, we don't do 1 times anything. Oops, not 16, 6. Divide that by 4, divide the bottom number by 4. So these two numbers are being divided by 4, plus and minus. Now, I also don't need this minus on the bottom, but again, if you leave it in there, I'll go ahead and still count it as correct because it's just not something that we see all that often. I mean, this is probably like the second time you're ever seeing this. I wouldn't be surprised. So if you leave that negative there, whatever, I'll take it. But in this case here, it looks like actually this is our answer. So x equals the solution set of positive and negative root 6 over 4. And there's not much else we can do with this. So box that up and we are done with that one. Let's go ahead and move on to this one here. Negative x squared. Make sure that you go in order of x. So this is a regular number. So all I'm going to have to do is minus 8 from both sides, and that should free my 0. So now I have this side equal to 0. So now this one has all of the numbers pretty together. All right, just a heads up, I'm getting a warning on my screen. And usually when that happens, it might cut out. So if that happens, just try to get back in, I guess. But I'm going to try to get through this as quick as I can, just because internet can be a little unstable at times. B squared, so I'm just going to go, I'm going to just skip that and go to 100 because I already know that 10 squared is 100. Minus 4ac. Okay, all over 2a, which my a value is 1. All right, again, I'm going to just set this up as quickly as I can. Negative 10 plus and minus square root. And again, I already evaluated that. So 100, well, hold on, I have 3 negatives. So that means this is actually going to be a minus. I can ignore the 1 because anything times 1 is always going to be that same number. 4 times 8 is 32. Which it is, all over 2 times 1, which is 2. And I think this one's going to turn out pretty good because I know that 100 minus 32 is going to be 64. And I'm thinking this is going to be an example. Oh, wait, hold on. 100 minus 32 is 68. Okay, not 64, it's 68. I thought this was going to be a whole number because to me it looked like it would have worked out as a whole number. And I thought to myself, wait a minute, 2 minus, anyway. So it's going to be 68. So I guess if it was 64, that would have been nice because it would have just been 8 and we would have had whole numbers to work with. But we still have that irrational. So now we got to get rid of this 68. So 68. And think of large numbers. Think of square numbers. So let's think of some square. You know, I think I just found I think I might get a better way to do this. 4, 9, 16, 25. I think I just invented a whole new method right here on the spot because I've never seen this done before. So let's get some square numbers out of 68. So can I times something by 68 to get 4? And in this case, it's 17. And we could check these other ones, but I'm actually sure they're not going to work. So we could check for square numbers like that. That's actually a really good method. I think I'm going to stick with this forever. You just witnessed the creation of a new method. Anyway, so 17 cannot be broken down anymore, so that means I'm going to have to leave that one as is. So negative 10 plus and minus, and I'm going to take the square root of 4, which is 2. 17 is going to stay in there because I can't take it out. And then from here, I would just divide everything by 2. So I'm ready to put my answer together. So simplify here. Negative 10 divided by 2 is negative 5. Plus and minus 2 divided by 2 is 1. And that's going to cancel out the 2 because there's not going to be any more 2 there. So that is it for this one here. So again, I just divided both of those coefficients by 2. That one and that one. But I think this is a really good thing, and I'm gonna show you a little bit more. But basically, you just list the square numbers and see which one is going to be the biggest one. And you could go on and on. You could go with like 36, 49, and stuff like that. Maybe if it was a really big number, like in the thousands. Anyway, let's go ahead and move on to the last set of problems. In case you were still looking at this one. But again, that internet is not so good today, so try your best to keep up. Maybe at the end, if you need to, we'll go back on some of these. Okay. Now something looks like a trick because this one's already in order. Since this one's already in order, it makes me think that they're going to pull another trick on us. Well, if it's a trap, I guess we're going to have to find out, and there's only going to be one way to find out. So take our coefficients, 8, negative 7, negative 3, and plug it in. Negative 8 plus and minus negative 8 squared minus 4ac all over 2 times our a value, which in this case is negative 3. So there's quite a lot of stuff going on, but I don't see anything weird going on just yet. But again, I'm going to have to approach this one with caution because I'm kind of, it's kind of weird that they would give us an easy one. What looks easy. All right, so 8 squared, oh wait, hold on a minute. 8 squared is not 16, it's 64. Almost walked into that one. Now, I have 3 negatives, so that's going to be a negative here. 4 times 3 times 7, and that's going to be 84. Okay, now I see it. Now I see what the trick is to this one. The trick to this one is, well, okay, maybe you can't see it yet, but let's go one more step and see if you can spot what is wrong with this one here. 64 minus 84 is negative 20. Now, if you remember anything about radicals or square roots or any kind of root, like cube roots or fourth power roots, or any kind of roots, like I said, you cannot have a negative in there, right? Because what number can I square to get negative 9? Well, the first thing I'm going to get is, well, what about negative 3 times negative 3? No, because remember, negative 3 times negative 3 is positive 9. So in other words, this one can't really be done. But remember, we have a special rule for getting around these kind of problems. So first off, I am going to break down everything I can inside of this radical. So negative 1 times 4 times 5. Now these 3 numbers make up negative 20 because 4 times 5 is 20. 20 times negative 1 is negative 20. So if we were to put all these numbers back together, it would be negative 20. So it's factored down all the way. And again, notice how I took out the negative 1 and made it its own factor. Now I'm going to have to break out as much stuff as I can. So negative 8 plus and minus. I can take the square root of 4. I know the square root of 4 is 2, so I'm going to take that as the square root. But there's one more thing I can take out. If you remember, I is equal, oops, almost put it backwards. Square root of negative 1 equals the special variable I, or imaginary number. So I'm going to take out this -1 and put it out front as I, so that way it is now an imaginary number. Don't forget the 5 because we cannot take that out. There are no other numbers that we can factor 5 into that make it a nice number. So in this case here, I get -6. All right, and now let's go ahead and reduce this as much as we can. Now I can't reduce it all the way because I can divide all of them by 2, but nothing, it's not going to cancel the bottom number out. So in this case, I'm going to get, I'm going to just write my answer here. So x equals the set of numbers of 4 plus and minus I root 5 all over, it's not a very good, nope. So again, divide everything by 2. So -6 divided by 2 is going to be 3. Now again, I should say -3. And if you put -3 down here, I'm fine with that. But in this case here, since there's a plus and a minus, it doesn't make sense to divide it by a negative. But again, that's also such a rare instance that I just don't think very many people, including like, I don't know, other math teachers might even forget that. College students would probably forget that. Because again, it is really rare that something like that pops up like that, enough for it to be spotted and worked with a lot easier. So anyway, there we go, we're done with that one. So that's the trick to this one, is that there's an imaginary number, which quadratic formula not only works with irrational numbers, but it also works with imaginary numbers. And again, it's probably not impossible. I think you could probably use completing the square on this or something, or rooting both sides, the square root method. But it would be hard to do this one because it is both an imaginary number and a fraction and an irrational number. So it's actually all 3 of the worst things that you could have on a problem like this. So that's why something like this is just so easy to have one method to do everything with. Okay, it's like the industrial strength wood chipper. Okay, nothing can stand up to it. Okay, it's like the biggest hammer on the work site. Nothing can, it's like the biggest tractor on the work site. Nothing can stand up to it. And then here I'm at the -5, so 4 minus 5 is going to be 4. Make sure it's in the right order. Make sure it's set to 0. Plug in our A, B, and C. All right, so B value, and again, it's going to be opposite of that one, so 4. It's going to be +4, and just a reminder, I know I've been skipping this step because there's a negative here, and then there's one here. Negative times negative is just going to make it positive, so that's why I've been skipping that step on the past couple of those things. B squared, and this is also going to be -4 times -4, which is going to be +16, and again, that just cuts out one step. -4 times A times C. If you want to do all of the steps, because you're afraid that you might make a mistake between doing some of these in your head, then yeah, definitely go ahead. But I'm just doing this again just because I'm going to try to get this done before anything happens, because this week has been a really tough week with the internet. The internet's really been kind of off and on, or on and off. I don't know how you'd say that. Okay, it's been really iffy. You know, I mean, I think on Tuesday or something, I wasn't even able to do attendance because the internet just kept going out several times. And I actually forgot to put the A down here, the 2A down here. But I can fix that really quick. I'm gonna put 10 and all divided by 2A. Okay, so I could also write it like this. So if you're ever using like Microsoft Excel or Desmos, you could use something like this. It'll look something like that, where you can type it all on one line. Like some computers, some calculators, they make you type everything on one line and they don't allow you to use fractions. So you'd type it like that. 16 minus 80. And that would be negative 64, which 64 is a root number, but negative 64, probably not. Now, since I know the square root of 64, I'm going to take that out. Square root of 64, as we know, is 8. But then we have a negative 1 in there, right? There's a negative 1, just like how we split the negative 1 right here. We're going to take that out, and that is also going to be I. Now again, look at these three numbers. It's like just like an ordinary fraction, but this one has three numbers. We have to simplify all three of them at once. So 4, 8, and 10. Is there a number that can divide into 4, 8, and 10? Yeah, right. We have one. We can divide everything by 2. So that's what we're going to do. We're going to divide everything by 2. Everything by 2. Check it again. Make sure there's no other numbers because, well, 2 and 4 can also be divided by 2, but 5 cannot. So no, there is nothing else we can divide all of these by. And it looks like this is going to be our final answer. So let's go ahead and put that into our form. And in this case, I'm just going to write everything as is. I am not going to change anything because we have already gotten it to simplest form as far as it will go. Whew, that was quite a bit of a lesson. I think that's been one of our longer lessons this year. But again, it's not really tough, so don't be intimidated by it. Just as long as you remember to identify your variables, plug them in where they go, and do your best to evaluate them. And I'm going to go a little bit easy on some of these. So if they're a little bit off, like a minus or a plus somewhere or extra, fine, I'll kind of leave it alone. But yeah, I think that's it for today. Keep in mind that we only have 2 more weeks, which is not that long. There's a big packet that was sent out, so it should be enough, because remember that your attendance also is counted by what you turn in. So I had to kind of create a small packet. So next week, you're probably going to get like a tiny packet. And maybe this week you should have or will get a larger packet that has 2 packets in it. One of them is the final exam, and I'll go ahead and go over that one as we get closer to the end of the year and on how that works. Because there are some kind of rules, and it's kind of like board game rules. But yeah, I'll explain it when we get there. Anyway, that'll be it for today. So I will go ahead and get ready to sign off, and I will see you next time. Bye-bye.
Okay, bye.